Good day, everyone. Welcome to the free elective specialized subject. Today, I am the part 1 presenter, Margie A. Piedraverde, and I will going to discuss the topic bridge components. So, for the outline of the topic, we have here the A, abutments, B, bearings, C, deck, D, reinforced concrete, E, pre-stressed concrete, F, composite. Also, we have here the following to be reported with my co-reporters. G, steel box girder. H, steel truss. I, cable stayed. J, suspended bridge deck. K, through arc bridge. L, suspension. We have also here the M, structural behavior. N, variations. O, drainage. P, footings or foundations. Q, modern foundation types. R, monofile foundation. S, parapets. T, parapet roofs. U, piers. V, wing walls. And W, seismic retrofit technology. And lastly, we have the soil structure interaction. So let's proceed. For the introduction of this topic, there are different types of bridge depending upon the specific physical and design scope requirements. In this topic, we will discuss the components and parts of the bridge. So it is important for us as a future engineer to masterize the components and parts of a bridge in order for us to design our project well and with knowledge. A bridge is a structural built to span a physical obstacle such as a body of water, valley, or road without closing the way underneath. Most likely, the earliest bridges were falling trees and stepping stones. So, noong unang mga nakaraan, noong unang panahon pa, ang ginagawa nilang bridges are the fallen trees and the stepping stone. So, the first one na gumawa nito are ang mga Wellinioblihiv people. I don't know the correct pronunciation. So bear with me. Build the boardwalk bridges across marshland. It is constructed for the purpose of providing passage over the obstacles, usually something that can be detrimental to cross otherwise. So let's proceed with the topic A, abutments. Abutments are vertical structure used to retain the earth behind the structure. The dead and the live loads from the bridge superstructure is supported by the bridge abutments. So, ang bridge abutments, ito yung mga something like the retaining walls sa ating mga dikes, something siya ganyan. Pero ang bridge abutment, ito ay ginagamit sa ating mga bridges in order to support our bridge from any lateral for any forces or any lateral loads from the bridge superstructure. When we say bridge superstructure, these are the parts of the bridge on the top of the abutments, such as decks, the beam, or basta yung mga nakikita natin sa taas na parte ng ating bridges. Sila yung mga superstructure. The design loads on the abutment is mainly dependent on the type of the abutment selected, the sequence of the constructions. The special care has to be provided for the foundations of abutments. The abutment foundation must overcome the problems of differential settlement, excessive movements caused due to lateral forces or loads. So we have also to consider the settlements of the soil and also the lateral forces or loads that are present sa atuang bridges in order to design our foundation of abutments with great outcome. So next we have here, let's proceed with the design consideration of abutments. So load transmitted by the bridge deck onto the abutments. So these are the following loads that can be transmitted from our superstructure to our abutments. So first we have the vertical loads from the self-weight of the deck. Second, the vertical loads from the live loading conditions. And the third one is the horizontal loads from the temperature, tip movements, and etc. So these are the environmental loads, as we all know. Then number 4, we have the horizontal loads from the braking and skidding effects of the vehicle that passes through our bridges. So these loads are carried by the bearing which are seated on the abutments bearing platforms. So ang ating bearing is makikita sa ating abutments na kung saan the horizontal loads may be reduced by depending on the coefficient of friction of the bearings at the movement joint in the structure. So nakadepende rin kung anong magiging epekto nito sa ating bearings depende nakadepende siya sa coefficient of friction na magpo-provide ng ating loads from the superstructure down to our abutments. And doon sa abutments, makikita natin ang ating tinatawag na bearings at ang ating mga loads are ang ating loads, kung gaano kabigat ang ating loads ay nakadepende rin sa kanya kung gaano kalaki or gaano kaliit ng coefficient na marireceive ng ating bearing sa baba. In the structural loads, horizontal pressure exerted by the film materials against the abutment wall is to be considered. Vehicle loads at the rear of the abutments are considered by applying a surcharge loads on the rear of the wall. So also we have to consider the rear part of our bridges. That's why it is important to apply a surcharge load. When we say surcharge load, it also something that is reinforcement in order for us our soil or our earth on the backside of our bridges will not collapse due to the vehicle passing through our bridges. So next, let's proceed with the topic 5B, the bearings. So as you can see in the picture, these are the parts of the bearing and also the actual photo of a bearing. Bridge bearings are devices for transferring loads and movements from the deck to substructure and foundations. So ang bridge bearing is considered as the one will hold our loads from our superstructure. Diba, nasabi ko naman kanina kung anong superstructure. These are the decks and beams from the top of our bridges or the surface of our bridges. And these loads that provide mga loads na makukuha natin doon ay mapupunta sa ating substructure which is our bearing. Sa kanya mapupunta, sa bearing ang mapupunta ang mga loads nating makukuha doon sa ating superstructure. And also, from the bearing, it will goes down to our foundation. In highway bridge, bearing movements are accommodated by the basic mechanism of the internal deformation, the elastomeric, sliding PT, FE yan siya guys, or rolling. A large variety of bearing have evolved using various combination of these mechanism. So later we will know one by one of them. So first, we have here the design consideration for our bearings. The function of each bearing type are. So ito sila, elastomeric, sliding PTFE, and roller. So let's know them one by one. The elastomeric bearing allows the deck to translate and rotate, but also resist loads in the longitudinal and transverse vertical direction. So, ang kanyang purpose is nahayaan niya ang ating deck para magkaroon ng translate and rotate the forces, but also can also resist our longitudinal and transversal and vertical direction. Loads are developed in movements as accommodated by distorting the elastomeric pad. Ang elastomeric bearing is para siyang part lang din siya na abutments na kung saan naka-layer doon ang ating mga pads like elastomeric pads, like the PTFE, and pwede din siya maging ruler para kumbaga they will serve as a reinforcement from our forces from the superstructure in order to resist either rotation, transverse, and vertical direction. For the elastomeric, we have here the for the elastomeric bearing. This one is resisting the loads in the longitudinal and transverse and vertical direction. But however, it allows the deck to translate and rotate. Yan ang purpose niya. So let's proceed with the sliding PTFE. A plane sliding or sliding bearings usually consist of a low friction polymer, or ang abbreviation of PTFE is what we call the polytetrafluoroethylene sliding against a metal plate. So meron tayong PTFE na nakaslide sa ating metal plate. This bearing does not accommodate rotational movement in longitudinal or transversal direction and only resist loads in the vertical direction. So kanina nagre-resist yung ating elastomeric sa kumbaga sa vertical or horizontal, ano pa ba yun, ng mga direction. But dito sa ating sliding, nagre-resist siya ng vertical direction but does not accommodate also the rotational and longitudinal and transverse. So parang kabaliktaran din siya ng ating elastomeric. So it is like a pad lang din, pero ang kaibahan niya is meron siyang metal plate na parang naka-sandwich or naka-attach sa kanya, na kung saan doon sila nagsaslide in order to resist the vertical direction of our loads na pwedeng mapunta sa ating bearing from our superstructure. Longitudinal and transverse loads can be accommodated by providing mechanical keys. The key resists movement and loads in a direction perpendicular to the keyway. So, pwede din nating i-reinforce ang ating longitudinal and pwede din natin ma-resist ang ating longitudinal and transverse load during using the mechanical key. So, we have also here the next one type, the rulers. Large longitudinal movements can be accommodated by this bearing. So, dito naman ay longitudinal bearings or movements na naman ang kanyang kayang i-resist. But vertical loads only can generally be resisted. The designer has to assess the maximum and minimum loads that the deck will exert on the bearing together. With anticipated movements or translation and rotation, bearing manufacturer will also supply a suitable bearing to meet the designer requirements. So, as we all know, ang mga designer hindi naman din kumbaga nagpo-provide or nagbibigay ng ganyang klaseng design kung hindi kinakailangan. So, ang mga designer is gumagawa ng design na nakabase sa mga loads na pwedeng magpas sa ating bridges and ano pa ba yung mga pwedeng i-consider upang maging strong enough ang ating bridge or mag-withstand ang ating bridge. But it is also important na yung mga design na nagawa ng ating mga designer is also meet the supply in the materials that we will be using sa ating bridges. That's why it is important para sa mga manufacturers na magbigay din ng mga tamang klase ng mga bearings na paggagamitin during the construction of the bridge. Bearings are arranged to allow the deck to expand and contract, but retain the deck in its correct position on the substructure. We have also the fixed bearing and sliding guided bearing. So next, we have the topic 5C deck. The decking is considered as the road or the rail surface of the bridge. So para siyang ganyan na nasa picture na makikita natin. It is plainly the surface of the bridge na makikita natin kung saan nagpapas yung mga vehicles or any live loads na dumadaan sa ating bridges. The decks are supported by the girders or the huge beams that is in turn supported by the piers. The whole arrangement is supported with a deep foundation, mainly piles and cup arrangement. So, uh, para dito, ang superstructure natin, nandito na, parang nakumpleto na yung parts ng ating bridge. I mean, oo, kung saan matatransfer ang ating loadings. So para sa superstructure, we have the girders, beams, and decking. However naman sa ating substructure, we have the bearings. We have also the bearings, yung mga na-discuss natin kanina. And para naman sa foundation, we have the piles and cup arrangement. Also, we consider also para sa substructure, we have also the piers. Yan sila. Ano bang tawag sa kanila? Decision-taking at preliminary design stage will influence the extent to which the actual structure approximates, to the deal, but so will decisions taken at detailed design stage. Consideration of each of the ideal characteristic in turn will give some indication of the importance of preliminary bridge design. So importante din na magkaroon tayo ng preliminary bridge design upang makita natin or ma-evaluate natin ang mga design na pwede nating gamitin sa ating bridge construction, and also in order for us to know the every details sa ating design stage and even sa ating construction, kung ano ba yung pwedeng mangyari sa ating construction. That's why it is important to have a preliminary design stage or for our bridge. Hindi naman din tayo pwedeng basta-basta na lang gumawa ng bridge, dahil ang bridge is one of the hectic or kumbaga mga mahihirap na infrastructure na pwedeng ipatayo ng isang engineer or any construction company. So next, we have also the continuation here, the preliminary design for making the correct choice of bridge type. So ito ang ating mga i-consider. We have here the safety, the serviceability, the economy, and the appearance. Sa safety, the ideal structure must not collapse in use. It must be capable of carrying the loading required of it with the appropriate factor of safety. This is more significant at detailed design stage, as generally any sort of preliminary design can be made safe. So dapat sa preliminary design pa lang, makikita na doon kung gaano ba ka-safe ang ating bridges. Dapat makita na din ang transparency kung ano yung factor of safety natin for our bridge. Kung capable ba siya na magdala or mag-transmit ng ating mga loadings na pwedeng or possible na dadaan sa ating bridge, such as our dead loads and even our live loads, na kung saan masasabi nating hindi talaga magkakaroon ng collapse. Hindi magko-collapse yung ating infrastructure. So safety is very important para hindi lang din para sa infrastructure itself, but also sa mga public or sa mga taong pwedeng dadaan sa ating bridge, na dapat i-consider natin ang main purpose ng ating bridge na makapagbigay ng easy access sa mga tao at hindi kumbaga hindi catastrophe ang kanyang pwedeng ibigay. Yan. And next, we have serviceability. The ideal structure must not suffer from local deterioration or failure from the excessive deflection or vibration. It must not interfere with the sight lines on the roads above or below it. Detailed design cannot correct faults induced by bad preliminary design. So para dito sa serviceability, kailangan din natin i-consider ang mga deflection, or dapat in the first stage pa lang sa ating process for the bridge making, not bridge making, bridge construction, or even in the preliminary design, is dapat ang serviceability ng ating bridge is clear enough na upang masabi natin na safe talaga ang bridge, and kaya niyang mag-withstand for how many years or how many service life na kanyang pwedeng ibigay, and also kaya niya rin withstand ang too much deflection na pwedeng may bibigay nating loads or vibration from any vibration from the dead loads, and even from the environmental hazards, ganyan. The next, we have here the economy. The structure must make minimal demands on labor and capital. It must cost as little as possible to build and maintain. At preliminary design stage, it means choosing the right types of materials for the major elements of the structure and arranging this in the right form. So, economy is also one of the most important kung paano ba natin, paano natin i-spend ang ating total cost or total money for the bridge, for the construction of the bridge, ganyan. And also, kailangan natin i-minimize ang ating, kumbaga, kailangan natin ma-minimize ang labor and also capital na kung saan sakto ito sa ating pangangailangan lamang na para ma-build and maintain natin i-build and maintain natin ang ating bridge mismo. And also, we have also to consider the first thing talaga also, ang mga materials natin paggagamitin sa ating bridges. Nasabi ko naman din yan kanina na kailangan ang ating mga materials ay dapat nakamit doon sa mga requirements and also sa mga na-design ng ating designer upang also para ma-consider talaga na nasunod natin yung ating design. And also, ang mga materials na ito ay dapat correctly, or kumbaga, hindi man siguro sa sakto lahat, no? Pag mag-design ay mag-construct na tayo ng ating bridges. So, approximately na lang siguro ang tamang words sa ating paggagamitin upang maisagawa natin ang construction process ng maayos and according to the plans. Ganyan. So number 4, for the appearance, the structure must be pleasing to look at. Decision about forms and materials are made at preliminary design stage. The sizes of the individual members are finalized detailed design stage. The preliminary design usually settles the appearance of the bridges. So dito din sa ang daming nagaganap sa preliminary design stage, no? Sa preliminary design stage pa lang pala, nalalaman na natin kung ano ba talaga yung total appearance ng ating bridge, kung ano yung mga materials, kung ano yung forms na gagamitin natin, sizes na siguro ng mga beam na paggagamitin natin, kung ano yung mixture ng ating concrete ating gagamitin, ganyan. So, kailangan talaga na lahat ng detalye siguro not siguro, lahat ng detalye dapat is makikita na talaga natin sa preliminary design upang sa ganun, also on the appearance of our bridges or bridge is also appealing or pleasing to the other. Kumbaga, hindi lang siya, kumbaga, inilagay o kinonstruct dyan sa isang specific area for serviceability para sa maka-access ang mga tao from one places to another. It also gives us the kumbaga parang tourist spot look siguro kung maituturing, ganyan. So next we have the constraints. So we have kanina na-discuss ko ang about sa mga na-discuss ko na yun, mga serviceability, ganyan. Ngayon, proceed tayo sa constraint na pwede nating ma-encounter during our decking process or construction. If the bridge is to cross a road that is on a curve, then the width of the opening may have to be increased to provide an adequate sightline for the vehicles on the curved road. It is important to determine the condition of the bridge site by carrying out a comprehensive site investigation. Pwede tayo magkaroon ng ground investigation and testing, covers the requirements for the soil survey. So, importante din ang ground investigation and testing. Other topics which needs to be considered. Ito rin ang mga pwede natin i-consider, existing services, gas, electricity, water, etc. Rivers and stream, liability to flood, kung gaano ba kadalas, ganyan, na pwedeng magka-flood doon sa river. River kung saan natin siguro ilalagay ang ating bridge. Existing property and rights of way. Ano bang mga right of way natin doon, nandoon sa ating site. Access to site for construction traffic, ganyan. Kailangan din natin yan. Siguro ito yung mga apat na mga variables na ating considered na most mahirap na i-resolve during the construction of the deck. Pero as far as I know, itong number 2, liability to flood, hindi naman ito natin mapipigilan, ang rivers and streams. So, it is also important to prepare na lang talaga if we are the project we are assigned on the said project or we are the project team leader. And so also here the preliminary design consideration. So kanina meron tayong constraint. Yan naman, we have here the preliminary design consideration. First, a span to depth ratio of 20 will give a starting point for estimating the construction depth. 2, continuity over supports. First, we have the reduces the number of expansion joints. Kailangan natin i-reduce ang expansion joints. Reduces maximum bending moments, enhance construction depth or material use. Increase sensitivity to differential settlement. So, kailangan din natin yung mga settlement, soil settlement, i-consider din natin upang talagang masabi natin na ating support sa bridge is okay. The next, we have the factory made units. First, we have reduces the need for soffit shuttering or scaffolding used when the headroom is restricted or access difficult. The next, we have reduces site work which is weather dependent. Sa mga weather dependent na mga trabaho, so kailangan natin talaga i-consider ang ating weather. So it is important talaga na every day in the morning, kailangan natin i-check ang ating weather forecast in order to know kung ang araw ba ito is good for construction. Third, dependent on delivery dates by specialist manufacturers. So, also alam naman natin ang bridges talaga is more on ang parts nito or mga components nito is factory made delivery. So, paminsan hindi naman natin inevitable naman talaga na paminsan ay madidelayed yung ating mga materials, delivery ng ating mga materials. So, we have also to consider that one in order for us to para sa umpisa pa lang maka-prepare na tayo. The next, special tend to expensive. So, ang mga bridges naman talaga, it takes sa foundation pa lang. Diba? Napakamahal na. So, ito talaga ang mga kailangan i-consider. Next, special permission needed to transport units or more than 20 meter long on the highway. Diba? Meron naman talagang, rules na bawal yung mga kakaalam ko 10 meters ata. I'm not that sure na bawal i-transport yung mga bagay na matatalas, ganyan. Pero dito more than 29 meters long on the highways, bawal na siyang kumbaga i-transport. So, kailangan din natin ang permission. So, paminsan din naman is na delayed yung ating mga permission or letter of permission siguro na may tuturing. That's why kailangan din natin i-consider ang mga panahon na ito. Okay? Then next, we have number 4, length of structure. The shortest structure is not always the cheapest. By increasing the length of the structure, the embankment, retaining wall, and abutment cost may reduce, but the deck cost will increase. So, ganon. Hindi lahat ng pagkakataon daw ang ating structure is not always the cheapest when it is the shortest. But also, ang ating retaining wall, ang length ng ating pag ang ating embankment is ating in-increase ang length, ang retaining wall and abutment cost ma-reduce. But however, the cost of the decks also increase. So it is para sa akin it is a vice versa. So next we have the substructure. The structure should be considered as a whole, including the appraisal of years. So later my group mates will also report about the years, abutments and foundations. Alternative designs for filed foundations should be investigated. Filing can increase the cost of the structure by up to 20%. So let's proceed to topic D, the reinforced concrete. So siguro mostly naman sa atin alam na yung anong reinforced concrete since meron na naman din tayong subject noon na reinforced concrete. So it is just a kumbaga glimpse na lang for our topics. Topics. Reinforced concrete decks. The 3 most common types of reinforced concrete bridge decks are: first, we have the solid slab bridge decks, are most useful for small single or multi-span bridges and are easily adaptable for high screw. The next, we have the voided slab and beam and slab bridges, are used for larger and single multi-span bridges. Circular voided decks, the ratio of depth of void over the depth of slab should be less than 0.79. So we have to take note of this value, and the maximum area of the void should be less than 49% of the deck sectional area. So the analysis of decks. For the decks with a spool less than 25%, degree, a simple unit strip method analysis is generally satisfactory. For screws greater than 25 degree, then a grillage or finite element method of analysis will be required. Screws decks develop twisting moments in the slab which become more significant with higher screw angles. So, ganyan ang screw angles. So, extensive tests on the various steel arrangement have shown the best positions as follows. So, mani siya. There are 2 types of deck using pre-stressed concrete. Pre-tension beams with in situ concrete, post-tension concrete. So later we will discuss that one. Ito na pala. The term pre-tensioning is used to describe a method of pre-stressing in which tendons are tensioned before the concrete is placed, and the pre-stress is transferred to the concrete when a suitable cube strength is reached. So, proceed muna tayo siguro sa post-tensioning. So, sa post-tensioning is a method of pre-stressing also in which the tendon is tensioned after the concrete has reached the suitable strength. The tendons are anchored against the hardened concrete immediately after pre-stressing. So, nauuna yung ating pre-stress, nauuna yung ating process ng casting of bed. So first, binubuhusan yung ating bed, nabubuhusan siya. Yung mga duct, yan yung siyang tinatawag natin ng mga tendons. Tapos, kinakas natin yung ating concrete. Concrete na naman ang ating ilalagay. The next is tensioning of tendons. So, nauuna yung mga process of casting, ganyan. Nauna yung ating inuuna yung hardening of concrete, tsaka pa natin binibigyan ng kumbaga forces yung ating tendons and then stretch siya. Ganyan ang post tensioning. So, mas nauuna ang ating para din siyang pre-stressing, pero mas nauuna dito yung ating dapat nauna yung goal na dapat ma-reach muna ng ating concrete yung suitable na strength na kailangan natin before natin siya after natin siya bibigyan na or after natin siya bigyan ng forces yung ating tendons or bigyan ng tension yung ating tendons, ganyan. Parang ganito sa nasa last na picture natin dito sa letter C, anchoring the tendons at the stretching at the end. So from sa A, nagkinas natin yung concrete. Second, second din, tensioning of tendons. Then lastly, anchoring of tendons at the stretching end. Ganyan. Para malaman talaga natin kung ano ba yung desired or makakaya na tension ng ating tendons. Then there are three concepts involved in design of pre-stressed concrete. Pre-stressing transform concrete into elastic materials. By applying this concept, concrete may be regarded as an elastic material and may be treated as such for design at normal working loads. From this concept, the criterion of tensile stresses in the concrete was evolved. There are next, we have the number 2. The pre-stressed concrete is to be considered as a combination of steel and concrete with the stress the steel taking tension and concrete compression so that the two materials form a resisting couple against the external moment or the analogous to reinforced concrete concept. This concept utilized to determine the ultimate strength of the pre-stressed beam. So third, we have the pre-stressing is used to achieve load balancing. It is impossible to arrange the downward load due to dead loads, salt dead load, in which case of the concrete would be in uniform compression. So for here, as you can see in the figure 1-3.1, the stages of pre-tensioning. So first, kabaliktaran lang naman siya ng ating post tensioning. So first dito is nauuna yung anchoring or applying the tension to the end of the tension of the tendons, ganyan. So nilalagyan ng tension on both ends of our tendons. And next, kinakas natin yung ating concrete or binubuhusan natin ng concrete ang ating tendons. Then next is transferring of free stress, ganyan. Dito is kinakat na natin yung ating tendon. Ganyan siya. So kumbaga mas nauuna dito yung pre-stressing. Nauuna yung paghila natin sa tendons, pagbibigay natin ng tension, samantalang doon sa post tensioning is mas nauuna yung casting of concrete kaysa sa pagbibigay ng tension sa ating tendons. Ganyan. Ika nga post. Sabihin in the end na sa pre naman is mas nauuna yung pagbibigay natin ng tension doon sa ating tendons. So it is clear naman, no? So next, pre-tension ridge decks. Types of beam in common use are inverted T-beams, M-beams, and Y-beams. So ito yung mga kadalasan na ginagamit natin sa ating ridge decks. Inverted T-beams are generally used for span between 7 and 16 meters. So T-beams ang ating dapat gamitin pag ang ating span for our bridge is reaches from 7 to 16. And the voids between the beams are filled with in situ concrete, thus forming a solid deck. For the M-beams naman are used for the span of 14 to 30 meters and have a thin slab cast in situ spanning between the top flanges with the aim of forming a void slab-type deck. The top face of the bottom flange of M-beams cannot be readily inspected. Also, the limited access makes bearing a replacement difficult. As a consequence of this restriction, the Y-beam was introduced in 1990 to replace the M-beam. So, during the 1990 pala, meron palang changes. Ang Y-beam the M-beam is napalitan na ng Y-beam. This lead to the production of SY beam, which is used for span between 32 to 40 meters. So, kailangan natin pang take note ang mga span na pwede natin paggagamitin ang mga iba't ibang klase ng mga beams na ito na ating na-discuss dito ngayon. So, ganyan. Post-tension bridge decks. Post-tension bridge decks are generally composed of in situ concrete in which ducts have been cast in the required position. While the required position. When the concrete has acquired sufficient strength, the tendons are threaded through the ducts and tensioned by hydraulic jacks using against the ends of the member. The ends of the tendons are then anchored. So ito lang yung parang process lang din siya ng ating post-tensioning. Dito, tendons are then bonded to concrete by injecting a grout into the ducts after the stressing have been completed. So pagkatapos pala na ang tendons are nasa-stretch or na-anchored, nagkakaroon din pala ng pouring of our grout into the ducts para makumpleto na yung tinatawag natin na stressing. It is possible to use a precast concrete units which are post-tensioned together on site to form a bridge deck. So pwede din pala natin pagsabay ang ating precast na concrete. When we say precast na concrete is kumbaga, prefabricated na yung ating concrete, kumbaga sa manufacturing company na mismo or sa mga bodega ng ating manufacturer, ginawa yung ating concrete. And then, pwede na siyang gamitin together with our post-tension na concrete sa ating bridge deck. So, sa enlightenment lang na pwede palang ipagsabay ang dalawa, ang precast concrete and then ang post-tension. So next, let's proceed to my last topic, the composite. Composite construction in bridge deck usually refers to the interaction between the in situ reinforced and structural steel. There are three main economic advantages of composite construction are: for a given span and a loading system, a smaller depth of beam can be used than for a concrete beam solution, which leads to economic in the approach of embankments. The cross-sectional, so number 2, the cross-sectional area of the steel top flange can be reduced because of the concrete can be considered as part of it. Transverse stiffening for the top compression flange of the steel beam can be reduced because of the restraint against buckling is provided by the concrete deck. So we have to take note of the following, The three main economic advantages of the composite construction. So for the construction method of our composite, generally the concrete deck is dapat magre-range lamang siya for 220 mm to 250 mm thick, with the beams or plate girders between 2.5 meter or 3.5 spacing, and the depth between the span is over 20 and span over 60. Composite action is developed by the transfer of horizontal shear forces between the concrete deck and the steel via a shear stud which are welded to the steel girder. So, ganun pala yun siya. Ang ating concrete deck and steel studs are being welded to our steel girders. So, ganun palang nangyayari, no? So, meron din siyang mga, standard measurement pala for our composite, for the composite deck para sa kanyang, for the concrete deck of our composite bridge. So yun lamang po. So, thank you for listening for my today's report. Salamat sa pakikinig and And thank you everyone, and God bless us all.
Good day, everyone. I am Paulo Yatan, and I am a party presenter of Bridge Components. So, in this topic, we will discuss toolbox girder, steel truss decks, choice of truss, cable stayed decks, suspended bridge deck, through arc bridge, tied arc bridges, suspension, and wire cable. First, let us talk about steel box girder. So, box girders have a clean, uninterrupted design line and require less maintenance because more than half of their surface area is protected from the weather. So, the box shape is very strong torsionally and is consequently stable during erection and in service. Unlike the plate girder, which generally requires additional bracing to achieve adequate stability. So that's why ang ating steel box girders have become prominent element in construction, especially in bridges or in river crossings, highway interchanges, and transit systems. So yun. So these types of structural elements are particularly attractive because of their high torsional stiffness, which are required when the bridge is curved. No? So that's why ating steel box girder are utilized for creation of curved bridge. But not only in curved bridge, it can also utilize in cables, supported bridge, as well as foot bridges. Yan. Next is the steel truss decks. So, trusses are generally used for bridge spans between 30 meters and 150 meters, where the construction depth or deck soffit to road level is limited. The small construction depth reduces the length and height of the approach embankments that would be required for other deck forms. So this can have a significant effect on the overall cost of structure, particularly where the approach gradient cannot be stepped as for railways bridges. So yun, it is a high fabrication and maintenance cost uh, has made the truss type deck. So in terms of labor costs relatively high compared to material costs. And when ang ating and when we're ang ating material costs are relatively high, then the truss is still an economical solution. The form of construction allows the bridge to be fabricated in small section of site, which also make transportation easier, particularly in remote areas. Next is the choice of truss. So this underslung truss is the most economical as the deck provides support for the live load and also braces the compression cord. So there is, however, the problem of headroom clearance requires under the deck, which generally renders this truss only suitable for unnav- unnavigable rivers or over flood plains. So the main purpose of truss bridge is to have all of its trusses to support the weight of its span over time. So and if its design is not made properly, they could be some trusses created that have zero pressure member. So which means that they would look nice but they are not working effectively effectively for the entire structure. So, yun. Yung natin ma-relate natin sa mga sinusolve natin na trusses, which is yung mga zero trusses pala na member, is ulit pulis, sa ating structure, So, yun. Next is the cable stayed decks. So in cable stayed decks, no. So cable stayed girders were developed in Germany during the Reconstruction period after the last war and attribute largely to works of Fritz Leonhard. Straight cables are connected directly to the deck and induce significant axial force into the deck. The structure is consequently self-anchoring and depends less on the foundation conditions than the suspension bridge. So, iyon. So, a cable stayed bridge naman offers a design, no, that is similar to suspended bridge, no, na ating itatopic pa later. So it will have, no, it will have towers that help to support structures. Just like ito nakikita natin, may towers, no, while the deck is held, no, in place by cables. So yun. So the difference between the design, no, is that cables hold the decks by connecting it directly to the support pillars instead of using suspending wires or cables to stabilize the span, just like sa ating suspended bridge, no, na ating pang ikatopic. So next is the suspended bridge. So ito yon. So suspended bridge deck is a structural element of several different types of bridges. Many designs use a number of vertical cables or bars in tension to support the deck. So these elements being attached to an overhead structures or some type. No? So through arc bridge, an overhead arc or in compression can support it suspended deck. So yun. Yun na. So the deck can be stiffened, no, by a truss, no, or by a girders element, no. So ang purpose of the stiffening element is to ensure na ang ating aerodynamic we have an aerodynamic stability, no, and to limit the local angle change in the deck, no. So yung suspension bridges natin are used, no, for only or for the spans of 300 to 2,300 meters. So yun. Next is through arc bridges. Sa through arc bridge naman, a through arc bridge, also known as a half through arc bridge and through type arc bridge, is a bridge made from materials such as steel or reinforced concrete, in which the base of an arc structure is below the deck, but the top rises above it. So the deck passes through the arc. Cables or beams in tension are Cables or beams in tension suspend the central part of the deck from the arc. So, yun, no? So, ang ating through arc bridge naman, no, is designed, no, so that the roadbed is suspended below the trusses, no, or arches, no, that makes up, no, the load-bearing structure of the bridge, no. So, so the roadway then passes to the trusses or arches instead of over them, no. So instead of over them, no. So yun. So meron tayong mga different types, no. Or we have many different types of bridge designs qualify as through bridges, no, including some truss bridges, arc bridges, and others. So, tide arc bridges. So, many tide arc bridges are also through arc bridges as well as tying the side loads of the arc. The tension member is also at a convenient height to form the bridge deck. As for a true arc. So the converse is not true. So the true arc which do not imply that they are tied arc bridges unless they also provide the deliberate tension member that is the key to a tied arc, no. So although visually similar, no, the tied and untied true arc bridge are quite distinct structurally and are unrelated in how they distribute their loads. In particular, cast iron bridges such as the Stanley Ferry Aqueduct must resemble tied arc bridge, but a cast iron is weak in tension. They are not structurally a tied arc. Sorry for that. Medyo malabo yung mata ko. So, yun na nga, no? So, ang ating type arc bridge daw are long span bridges, no? That are capable of connecting to roadways or walkways over a large bodies of water, such as rivers and bays. So, type arc bridges are differentiated, no, from other bridges structure, no, by the arc that spans over the bridge. So, meron itong cable and tension rod systems that connect the bridge to the arches. So, yun. Next is the suspension. So, a suspension bridge is a type of bridge in which the deck or the load-bearing portion is hung below suspension cables on vertical suspenders. So, outside Tibet and Bhutan, were the first example of this type of bridge were built in 15th century. So this type of bridge dates from the early 19th century. So bridges without vertical suspenders have a long history in many mountainous part of the world. So yan, suspension bridges can be struggle to support focused heavy weights, no? So ang goal nito, the goal of our suspension bridge is to continually transfer the tension and weight of traffic as it moves along the span, no? And all of the cable works together, no, to make this happen. So yun. So yun, no? So, next is, lastly, we have wire cables. Ito yung picture ng ating wire cables. So, the first wire cable suspension bridge was the Spider Bridge at Falls of Schuylkill, 1916. A modest and temporary footbridge built following the collapse of James Finlay Chain Bridge at Falls of Schuylkill, 1808. So ito yung pictures ng ating. So the footbridge spans was 124 meters. Although its decks was only 0.4 meters wide. So yun. So that's it. That's the end of my report. Meron pa tayong part 3 and part 4 nitong beach components. So thank you.
Good day, guys. I am Narvin Sitondog, the reporter, and this is the continuation of the bridge component. So, we have here the outline. First is the structural behavior, next is the variation, next is the drainage, Next is the footing or foundations. Next is the modern foundation types. Next is the monofile foundation. So, for the structural behavior, the main forces in a suspension bridge of any type are tension in the cables and compression in the pillars. Since almost all the force on the pillars is vertically downward, and they are also stabilized by the main cables. The pillars can be made quite slender, as on the Siberian bridge on the Wales England border. In suspended deck bridge, cables suspended by a tower hold up the road deck. The weight is transferred by the cables to the towers, which in turn transfers the weight to the ground. Assuming a negligible weight as compared to the weight of the deck and vehicles being supported, the main cables of a suspension bridge will form a parabola. Very similar to a catenary, the form of the unloaded cables take before the deck is added. Next is the advantages and disadvantages. Advantages is longer main span are achievable than with any other type of bridge. Next, less than materials may be required than other bridge type even at span they can achieve, leading to a reduced construction cost. Next is the except for installation of the initial temporary cables, little or no access from below is required during construction. For example, allowing a waterway to remain open while the bridge is built up may be better to withstand the earthquake movements than heavier and more rigid bridges. Next is the disadvantages. Number one, considerable stiffness or aerodynamic profiling may be required to prevent the bridge deck vibrating under high winds. Next is the relatively low deck stiffness compared to the other non-suspension types of bridge make it more difficult to carry heavy rail traffic where high concentrated deep loads occur. Next is some access below may be required during construction to lift the initial cables or to lift the deck units. This access can often be avoided in cable-stayed bridge construction. Next is the variations. This variation is underspan. This on the left side figure, I-bar chain cables of Clifton Suspension Bridge. For the next is the Yichang Bridge, a plate deck suspension bridge over the Yangtze River in China. In underspan suspension bridge, the main cables hang entirely below the bridge deck but are still anchored into the ground in similar way to conventional type. Very few bridges of this nature have been built as the deck is inherently less stable than when suspended below the cables. Here's are the example. Next is the suspension cable type. Suspension cable type, the main suspension in older bridge was often made from chain or link bars, but modern bridge cables are made from multiple strands of wire. Another reason is that as span increased, engineers were enabled to lift larger chains into position, where areas where strand cables can be largely prepared in mid-air from temporary walkways, deck structure types. Um, These contribute greater redundancy. A feud flawed strand in the 100 use pose very little threat, where areas, single, bad link, or I-bar can cause failure of the entire bridge. The failure of a single I-bar was found to be the cause of the collapse of the Silver Bridge over the Ohio River. And another reason is that the span increased, engineers were unable to lift larger change into position. Next is the deck structure types. Most suspension bridges have open truss structure to support the road bed, particularly owing to the unfavorable effects of using plate girders discovered from the Tacoma Narrow bridge collapse. Recent developments in bridge aerodynamics have allowed the reintroduction of plate structure. In the picture of the Yichang Bridge, note that very sharp entry edge and sloping. Here are the Yichang Bridge. Wait. That Yichang Bridge, a plate deck suspension bridge. In that picture, note that very sharp entry edge and sloping undergirders in the suspension bridge. This enables this type of construction to be used without the danger of vortex sheathing and consequent aeroelastic effect, such as those that destroyed the original Tacoma Narrow Bridge. So next is the forces. There are three kinds of forces operate on any bridge: the dead load, the live load, and the dynamic load. For the dead load, it refers to the weight of the bridge itself. Like any other structure, a bridge has a tendency to collapse simply because of the gravitational force acting on the materials of which the bridge is made. Live, live load refers to the traffic that move across the bridge, as well as normal environmental factors such as changes in temperature, precipitation, and winds. While the dynamic loads refers to environmental factors that go beyond normal weather condition, factors such as sudden gust of wind and earthquakes. All three factors must be taken into consideration when building a bridge. We have the list of longest span of bridges. The first one is the Akashi Kaiko Bridge, which 1909 m to 998. Next is the Sichuan Bridge, China. We have 1650 meters to 2009 meters. Next is the Great Belt Bridge, Denmark, 1624 to 1998. Next is the Yisun Bridge in South Korea, which is 1545 to 2012. Next is the Ronyang Bridge, which is 1490. Next is the Fort Nanjing. Here are the lists. We have here here in Philippines, the San Juanico Bridge. As you can see, it was the longest bridge here in the Philippines, and in Cebu they are as you got in the news, we have uh, new bridge in Cebu. Next, the drainage. Bridge drainage covers the collection and removal of waters from a bridge deck. To accomplish this function, drains are placed adjacent to curbs for collection of water, which is then either dumped directly on the ground or is conveyed to suitable disposal point. So makita mo gud nato, di ba? Same on road that the slope is we have the slope for the irrigation of water to go at the corner. So bridge deck drainage is divided into classes. First is the class 1 and the next is the class 2. Class 1, all location usually urban, where drainage must be carried via piping to some suitable disposal point, short verticals or near vertical downspouts to clear girders flanges are not considered in this category. Next is the class 2. All allocation usually rural, where drainage may be disposed of by free fall directly under the drain. Next is the four standard types of structured drains. Type A is, we have the type A, the type B, the type C, and the type D. To be used, type A is to be used for class 2 drainage at location adjacent to median curves where a grade is desirable. For the type B, to be used for class 2 drainage at location adjacent to barrier rail curves. For the type C, to be used for both class 1 and class 2 drainage intended primarily for use on steel or precast girder construction in deck areas where there is no main reinforcing running longitudinally in the deck to conflict with a drain of this size. This drain will intercept more deck runoff than other types. For the type D, to be used for class 1 drainage and is type of the most commonly used for this class. D1, it has a deep basin and is preferred when drains need to be located in interior base of box girded bridges. For the D2 has a shallow basin and is intended for use in deck overhangs. Make sure a D3 cannot be used before calling out of this drain. D3 is an improvement over the D2 drain and is preferred drain for the deck overhang. Next is the footing or foundation. A foundation is the lowest and supporting layer of a structure. Foundations are generally divided into categories: the shallow foundation and the deep foundation. So, before we build a bridge or we construct a bridge, so um, basically they have foundation like to hold the cable um, for the bridge to be for the cable to be handle the weight of um, weight weight of the bridge itself. Next, the earth fasts or post in in-ground construction. Buildings and structures have long history of being built with a wood in a contact with the ground. Most in-ground construction may technically have no foundation. Timber pilings were used on soft or wet grounds even below stone or masonry walls. In marine construction and a bridge building, a crisscross time timber or steel beams in concrete is called grillage. Next, the stone foundation. Dry laid stone foundation are common in many parts of the world. Next, the modern type foundation types. Shallow foundation, often called footings, are usually embed about a meter or so into soil. One common type is spread footing, which consists of strip or pads of concrete or other materials, which extend below the frost line and transfer the weight from walls and columns to the soil or bedrock. Shallow foundation, often called footings, are usually embed about a meter or so into soil. One common type is the spread footing. Another common type of shallow foundation is the slab-on-grade foundation, where the weight of the building is transferred to the soil through a concrete slab placed at the surface. Slab-on-grade foundation can be reinforced mat slab, which range from 25 cm to several meters thick, depending on the size of the building, or post-tension slab, which are typically at least 20 cm for houses and thicker for heavier structure. Deep foundation. Next is the deep foundation. A deep foundation is used to transfer the load of a structure down through the upper weak layer of topsoil to the stronger layer of a subsoil below. There are different types of deep foundation, including impacts, driven piles, drilled shafts, caissons, helical piles, geopires, and earth-stabilized column. The naming convention for different types of footings vary between different engineers. Historically, piles were wood, latter steel, reinforced concrete, and pre-tension concrete. Monofile foundation. A monofile foundation is a type of deep foundation which uses a single, generally large diameter, structural elements and embed into the earth to support all loads, weight, winds, etc. of a large above surface structure. A large number of monofile foundation have been utilized in recent years for economically construction fixed bottom offshore wind farms in shallow water, subsea location. For example, a single wind farm off the coast of England went online in 2008 with over 100 turbines, um, each mounted on 4.7 meters diameter monofile footings in ocean depth up to 18 meters of water. That would be all. Thank you.
Good day, everyone. So I am Christine Jin B. Asang, and I am the fourth presenter for our group, Bridge Components. So let's proceed. So my outline. So we're gonna discuss these terms: parapets, roofs, piers, wing walls, seismic retrofit technology, soil structure interaction. So our objectives is basically to know the following terms sa sinabi ko kanina. So parapets, types of parapet roofs, types of piers and the definitions, wing walls, seismic retrofit technology, and soil structure interaction. So what comes to your mind when you hear the word parapet? So para siyang isang maliit na wall sa roof deck or sa roof, di ba? So, based on Ramesh Shah, so parapet is a barrier which is an extension of the wall at the edge of the roof, terrace, balcony, or other structure. Where extending above a roof, it may simply be a portion of an exterior wall that continues above the line of the roof surface, or maybe a continuation of vertical features beneath the roof surface, or maybe a continuation of the vertical features beneath the roof, such as a firewall or a party wall. So let's proceed with we have samples of building parapets here from the book Bridge Engineering. So from the picture left, so it's elaborate the parapets flank the gable of King's College Chapel. It's from Cambridge. Next is modern naman dito. A modern parapet with electric lights function as a guardrail along the BP pedestrian bridge in Chicago. So, parapets. So, saan ba nanggaling ang word na parapets? So, it is from Italian parapetto. So, parare, to cover or defend, and petto means breast. So, basically, the use of parapets in tung unang panahon is defend. So, it is used as a defensive wall sa mga panahon na yun. So, parapets may be plain, embottled, perforated, or paneled, which are not mutually exclusive terms. So, we have plain parapets are upward extension of the wall, sometimes with a coping at the top and corbel below. Next is embottled parapet, may be paneled, but are pierced, if not purely as a stylistic device, for the discharge of defensive projectiles. So perforated parapets are pierced in various designs, such as circles, trefoils, or quadrifoils. So paneled parapets are ornamented by a series of panels, either oblong or square, and more or less in reach, but not perforated. So these are the common and decorated and perpendicular periods. So we have parapet roofs. So parapet surrounding roofs are extremely common in London. So common ang mga parapet surrounding roofs sa London. So this dates from the Building Act of 1707, which banned projecting wooden eaves in the cities of Westminster, London, as a fire risk. Instead, an 18-inch brick parapet was required. So with the roof set behind, this was continued in many Georgian houses as it gave the appearance of a flat roof, which accorded with a desire for classical proportion. So the Mosaic Law also prescribed parapets for newly constructed houses as a safety measure. So as a use of safety measure, yung mga parapets. So we have types of parapet roofs. So we have firewall parapets. So we have many firewalls are required to have a parapet, a portion of the wall extending above the roof. The parapet is required to be as fire resistant as the lower wall and extend a distance prescribed by the building code. So from the word itself, firewall parapet, it concerns or para siya sa fire resistant. So as you can see naman in the picture, in between siya sa dalawang houses as a fire resistant. So next is bridge parapets. So parapets on the bridge and other highway structures, such as retaining walls, prevent users from falling off where there is a drop. They may also be meant to restrict views, to prevent rubbish pushing below, and to act as noise barrier. So we have different kinds naman ng mga bridge parapets. So it concern is for the users na dili mahulog. Balain mo pud walay mga something parapet sa gilid sa bridge. It is very dangerous. So next is parapets and fortification. So what is fortification? So it is a defensive wall. A defensive wall to strengthen a place against attack. So parang ginagamit siya as a defensive wall sa when there is a war. So in terms of fortification, a parapet or breastwork is a work of stone, wood, or earth on the outer edge of defensive wall or trench which shelters the defenders. So dira sila gatago. It serves as a shield. So piers. So piers array structure including bridge and building supports and walkways, typically supported with widely spread piles or pillars. So piers have been built for several purposes, and because these different purposes have distinct regional variances, the term pier tends to have different of meaning in different parts of the world. So we have different kinds of piers depending on their purpose. So let's proceed. So types of piers. So piers can be categorized into different groupings according to the principal purpose. So nakadepende siya sa purpose o pag anong ang gamit ng pier. So however, there is considered overlap between these categories. So we have working piers. So from the word working, so it is built for handling of passengers and cargo onto the off ships or as the from one place to another. So yun. So working piers themselves fall into two different groups. So we have longer individual piers or are often found at the ports with large tidal ranges. So tandaan natin na large tidal ranges, yung longer individual piers, with the pier stretching far enough offshore to reach deep water at low tide. Such piers provided an economical alternative to impounded docks with cargo volumes were low or where specialist bulk cargo was handled, such as coal piers. So the other form of working piers is often called finger pier, as built at the ports with a smaller tidal ranges. Here, the principal advantage was to give a greater available keel length for ships to berth against compared to linear littoral quayside. And such piers are usually much shorter. So typically, each pier would carry a single transit shed, the length of the pier with ships berthing bow or stern into the shore. Some major ports consisted of large numbers of such piers lining the foreshore. Classic example being the Hudson River frontage of New York or Embarcadero in San Francisco. So in picture, this pier deals with varying water levels, ships forward by means of the stairs. So let's proceed to pleasure piers. Pleasure piers often include other amusement and theaters as part of the attraction. So basically, ang use ng pleasure piers is to entertain or to have people enjoy the place or the view, diba? As you can see in the picture naman, the colorful lights is very interesting. And it makes you enjoy or relaxed also. It's like pleasure from the word pleasure piers. So next is fishing piers. Many piers are built with the purpose of providing boatless anglers access to fishing grounds that are otherwise inaccessible. So for example, if you want to mamingwit dito sa tunga sa dagat, idaghag mga isda niyo makuha. So you can use that, diba? It's very enjoy mag-fishing. So next, so we have piers of the world. We have England and the Wales or Wales, Netherlands and Belgium. So we have trivia here. So at 6.5 kilometers or 4 miles, the remote terminal in Progreso, Yucatan, Mexico is the largest pier in the world. So what are the largest pier in the world? Progreso, Yucatan, Mexico. So next we have wing walls. So as you can see in the picture, this is the wing walls. Ito. So a wing wall is a smaller wall attached or next to a larger wall or structure. In a bridge, the wing walls are adjacent to the abutments, as you can see in the picture, and act as a retaining wall. So these are the example in the real life. So next, so classification of wing walls. Wing walls can be classified according to their position in plan with respect to bunks and abutments. The classification is as follows. So we have straight wing walls. They are used to small bridges, on drains, with low bunks, and for railway bridges in cities. So next is splayed wing walls. So these are used for bridges across rivers. So they provide smooth entry and exit to the water. So the splay is usually 45 degrees. Their top width is 0.5 meters. Face butter 1 in 12 and back butter 1 in 6. Whip holes are provided. Next is return wing walls. So they are used where bunks are high and hard or firm. So their top width is 1.5 meter and face is vertical and back buttered 1 in 4. Scour can be a problem for wing walls and abutments both, as the water in the stream erodes the supporting soil. So there are other uses of wing walls. So we have wing walls provide a smooth entry of water into the bridge site and support and protect the embankments. So wing walls can serve buttresses to support walls. They can also be purely decorative. Yeah, the wing walls also decorative. I find it cute, the bridge, as well as it provide a smooth entry to bridge site. So next is a seismic retrofit technology. So retrofitting of existing structure with insufficient seismic stance account for a major portion of total cost of hazard mitigation. So thus, it is of critical importance that the structures that seismic retrofitting are identified correctly and unoptimal heating is conducted in a cost-effective fashion. So we have conventional retrofitting methods. So it includes addition of new structural elements to the system and enlarging the existing members. So additional of shear walls and bracing. So conventional retrofitting methods is we have additional shear walls. You can see the picture. Additional foundation, jacketing, and additional columns. So retrofit of structure using innovative materials. It is very important, diba, na we are gathering research for us to have innovative materials that we can use in the future. So we have to solve the problem by researching. So the innovative materials na mga gamit natin is current research. Current research on advanced materials and civil engineering is mainly concentrated on high-performance concrete and steel and fiber reinforced plastic or FRP composite. So FRP composite materials have experienced a continuous increase of use in structural strengthening and repair applications around the world in the last 15 years. High specific stiffness and specific weight combined with superior environmental durability of these materials have made them a competing alternative to the conventional strengthening methods. So it was shown through experimental and analytical studies that externally bonded FRP composites can be applied to various structural members, including columns, beams, slabs, and walls to improve their structural performance, such as stiffness, load carrying capacity, and ductility. So So we have base isolation. So the seismic base isolation technology involves placing flexible isolation systems between the foundation and the superstructure. So by means of their flexibility and energy absorption capability, the isolation system reflect and absorb part of the earthquake input energy before this energy is fully transmitted to the superstructure. So reducing the energy dissipation demand on the superstructure, base isolation causes the natural period of the structure to increase and results in increased displacement across the isolation level and reduce acceleration and displacement in the superstructure during an earthquake. So this is not only provide safety against collapse, but also largely reduces damage, which is crucial for the facilities that should remain operational after severe earthquakes, such as emergency response centers, hospitals, and fire station. So base isolation can be used in seismic retrofitting of historic structures without impairing their architectural characteristic by reducing the induced seismic forces. So basically, ang base isolation is para ma-protect yung building against the damage caused by earthquake. So seismic isolation is proven to be a very effective method for protecting the buildings and other structures against seismic hazard. So an important disadvantage of the method, however, is that it cannot be applied partially to structure. Unlike most other seismic retrofitting methods, for this reason, the cost of base isolation is often significantly higher than alternative retrofitting method. This is often limit the application of base isolation to, first, special buildings such as certain industrial, research, public, and hospital buildings that contain sensitive equipment or strict operational and performance requirements. Two, historical buildings, the architectural and historic character of which may be harmed by alternative retrofitting methods. Third is the bridge, or which relatively less number of oscillators are required in installation is easier. So effects of seismic retrofitting on the structural performance. So based on structural performance. So the seismic retrofit techniques briefly presented in the preceding section vary in the mechanism that they decrease the seismic risk of structure. So selection of the particular retrofitting technique depends on the seismic demand, structural capacity, the required performance level, functional characteristics, and importance of the structure. So the main challenge is to achieve a desired performance level at the minimum cost, which can be achieved through a detailed nonlinear analysis. So basically, we are achieving a good quality structure and also at the minimum cost. So soil structure interaction. So most of the civil engineering structures involve some type of structural element with direct contact with ground. When the external forces such as earthquake act on this system, neither the structural displacement nor the ground displacement are independent of each other. So the process in which the response of the soil influences the motion of the structure, and the motion of the structural influences the response of the soil, is termed as soil structure interaction, or what we call SSI. So the effects of soil structure interaction on structural response. So it has conventionally been considered that soil structure interaction has beneficial effect on the seismic response of the structure. So many design codes have suggested that the effect of SSI can reasonably be neglected for the seismic analysis of structure. So this myth about SSI apparently stems from the false perception that SSI reduces the overall seismic response of the structure and hence leads to improved safety margins. So we have detrimental effects of SSI. So using rigorous numerous analysis, so my Milonakis and Gazetas, if I'm not mistaken, and I'm not sure about the pronunciation. So let's proceed. So have shown that increase in natural period of structure due to SSI is not always beneficial as suggested by the simplified design spectrums. So soft soil sediments can significantly elongate the period of seismic waves, and the increase in natural period of structure may lead to the resonance with the long period ground vibration. So additionally, the study shown that ductility demands can significantly increase with the increase in the natural period of structure due to SSI effect. The permanent deformation and failure of soil may further aggravate the seismic response of the structure. So that is why when the structure is subjected to an earthquake excitation, so having earthquake, so it interacts with the foundation and soil. That is why it's very important that you design the foundation very well, and also to find soil that is fit for the structure, and thus changes the motion of the ground. Soil structure interaction broadly can be divided into two phenomena. We have kinematic interaction and inertial interaction. So earthquake ground motion causes soil displacement known as free field motion. However, the foundation embedded into the soil will not follow the free field motion. This inability of the foundation to match free field motion causes the kinematic interaction. On the other hand, the mass of the superstructure transmits the inertial force to the soil, causing further deformation in the soil, which is termed as inertial interaction. So thank you, everyone. So I hope you learned something from us. Stay safe, everyone, and God bless.